How are you, everyone? I'm Alex Biamukama. Today, I wanna teach you a simple trick on how to get the valencies of radicals. Let's start with sulfate SO4. The sulfur atomic number is 16. Electronic configuration is T to 8 to 6, meaning that it is in group 6, and oxygen atomic number is 8. Configuration is T6. Oxygen gains 2 electrons, reacts by gaining 2 electrons. Therefore, oxygen has a valence of is 2. Oxygen has a valence of 2. But they are oxygen. We have 4 oxygen atoms from SO4. Now we have 4 oxygen atoms combined together. This one will make 2 times how many oxygen atoms? For this case, they are 4. Therefore, it is 2 times 4, which is 8. Which is 8. Okay, which is 8. Now we shall have S of oxygen. There are 4 oxygen atoms, each having a valence of 2 times 4, which is 8. The sulfur is in a group 6. You just write on top of sulfur 6. Then the difference, just get 8 minus 6 or 6 minus 8 without taking the magnitude, without the sign, and therefore 8 minus 6 is equal to 2. Therefore, a sulfate radical has a valence of 2. Valence is 2. Let's talk about the carbonate. Which is CO3. We want to know how can we calculate the valence of the carbonate, which is CO3. Carbon, which is 6, atomic number is 6, configuration is 2 to 4, meaning that carbon is in a group 4, right on top, group 4. Then oxygen, which is in number 8, atomic number is 8, configuration is 2 to 6, meaning that it has a valence of 2. 2 times 3, this is 6, and the valence now becomes 6 minus 4, which is 2, meaning that the valence of a carbonate is 2. CO3 carbonate has a valence of 2. has a valence of 2. Okay. Let's talk about the valence of a phosphate P or 4. Phosphorus, its atomic number is 15. Configuration is 2 to 8 to 5, meaning that phosphorus is in group 5. Oxygen, which is which is O, atomic number is 8. Configuration is 2 to 8, rather to 6. 2 to 6 has a valence of 2. 2 times 4 for 4 oxygen atoms makes 8, and 8 minus 5 is 3. Therefore a phosphate P of 4 has a valence of 3. Has a valence of 3 from 8 minus 5, which is the 3. Let's determine the valence of a nitrate, which is NO3. What is the valence of a nitrate? How can we determine the valence of a nitrate, which is NO3? Nitrogen, atomic number is 7. Configuration is 2 to 5. The the group of nitrogen is 5 on top of nitrogen. Oxygen, which has a valence of 2 times 3 is 6, and therefore the valence of a nitrate just get 6 minus 5, which is 1. Nitrate NO3 has a valence of 1. And let's talk about how can we determine the valence of, let's say, chlorate, which is ClO3. For this case, chlorine is number 17, Cl atomic number 17. Configuration is 2 to 8 to 7, is in a group 7 on chlorine. Oxygen, which has a valence of 2 times 3 is 6. Then 7 minus 6 is 1, meaning that a chlorate, which is ClO3, has a valence of 1. Has a valence of 1. It has a valence of 1. Let's talk about hydrogen sulfate radical. Hydrogen sulfate radical For this case, hydrogen is in group 1, 1. Sulfur is in group 6, 6. Oxygen 2 times 4, 8. Combine the groups together. This one will make 7. 1 plus 6 is 7. Therefore, hydrogen and sulfur, 7. 8 minus 7, which is 1. Therefore, hydrogen sulfate has a valence of 1. Let's talk about hydrogen carbonate radical. Hydrogen carbonate radical. Hydrogen carbonate radical. Then hydrogen group 1, carbon group 1, rather group 4. Then 4 plus 1 makes 5. Oxygen 2 times 3 is 6. Then 6 minus 5 is 1. Hydrogen carbonate has a valence of 1. Thank you very much for watching and listening. We meet in the next lesson.